Hi, welcome to my online classes. IIT Physics. So yes, in the last class I explained oblique projection of a body. Oblique projection of a body. If we project a body with initial velocity u, that is vector quantity. So this vector has horizontal component, that is on x-axis ux. Next, along y-axis uy component. Ux is nothing but u cos theta, uy is nothing but u sin theta. See, we projected a body with velocity u. That vector has horizontal component and vertical component. By using this, we calculated yesterday the total time of flight 2u sin theta by g, maximum height reached by the body, that is u square sin square theta by 2g, range equal to u square sine 2 theta by g. These three we calculated yesterday. Is it? Yes. So now I want to form a relation between these two. That is, in oblique projection condition, the relation between maximum height and range. See, this will be the range, that is Sx, the displacement on x-axis, that is nothing but range. So this one, the maximum height vertical displacement of the body throughout the journey. What is the maximum height reached in obliquely projected body? So how much time taken by the body to reach, not reach, to travel, it's a total journey, that is time of flight. So these three things I calculated yesterday. I explained clearly how do we calculate easily. Okay, now the relation between h max and range, h max and range. So here h max, maximum height reached by the obliquely projected body, obliquely projected body, then range equal to u square sine 2 theta by g. So here, what is the relation between these two? How do we calculate? The relation between these two at 90 degree, at 90 degree, that means the theta is equal to 90 degree. We are going to calculate. That means like this is x-axis, this will become y-axis. This is the initial velocity direction. It is making angle theta. If it is 90, that body will go like this. Is it or not? Is it or not? Yes. So the relation here, the relation between h max and range, the relation between h max and range, what is that? So just substitute at theta equal to 90, maximum height u square sine 90, that is 1 sine 90 degree square by 2g. So range equal to u square sine 2 theta, 2 into 90, so by g. Okay, see, keep this h max equal theta equal 90. This will become u square by 2g, u square by 2g. That means h max, maximum height reached by the body at theta equal to 90 degree. That will become u square by 2g, u square by 2g. So that means, how do we understand first? How do we understand? Say theta equal 90. Generally, if it is making theta, it will go like this. It will go like this. While it is making 90, the body will go perpendicular to horizontal. So maximum height reached by this body u square by 2g. This is nothing but the body is projected vertically up. The body is projected vertically up when theta equal to 90. So h max is equal to u square by 2g. Just you write at theta equal to 90. That is the body projected vertically. This is nothing but generally u square sine theta by 2g is obliquely projected body get maximum height. So that is nothing but here at theta equal 90, that is nothing but the body projected vertically up. It is equal to body projected vertically up. So that is I want to explain here. See, maximum height reached by the obliquely projected body sin u square sin square theta by 2g. When theta equal 90, the body is projected vertically up. That is equal to same. That will become u square by 2g. Just you write it. Okay. Okay. Now, so here what we calculated now, h max obliquely projected. That means at theta u square sine square theta by 2g. H max when theta equal to 90 u square by 2g. So this is obliquely projected body. This will become the body projected vertically up, projected vertically up. So both will this equation goes to u square by 2g. That is nothing but the body is projected vertically up. Okay. Next, I have a range. What is the range formula? Or u square sine 2 theta by g, u square sine 2 theta by g. So R max, when it will become the maximum range, the maximum range acquired by the obliquely projected body, when it will get maximum range. That means if we project a body, some body, see, I projected at theta 1, the body reached this height, this, the body reached, this is the maximum range. If I projected theta 2, so this making theta 2, obliquely projected situations. Initially I projected theta 1, the body got range R1. If I projected theta 2, the body got range R2. If I projected theta 3, the body gets R3, R2, third one will become R3. Which is greater here? R3 is. What about theta? This is a question. What about theta? Just you substitute here sine 0, 0, sine 30 degree 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, then sine 90 will become equal to 1. So sine theta, where sine theta goes to max? Sine 90 only. So u square sine 2 theta by g. If sine 2 theta will goes to 1, this total value become maximum. The range will maximum. So R max at theta equal to 45, sine 2 theta sine 90 is 1. So 2 theta equal to 90 degree. Just theta equal to what about theta? 45. Theta will become 45. So R max possible, maximum range possible when theta equal to 45. Then that is equal to u square by g. So already we got h max u square by 2g, u square by 2g. So you write this one, range at theta equal to 45. This is a side heading, you just keep it like this. Range, maximum range will acquired by that body at theta equal to 45, that is equal to u square by g. Okay, right. Are you copying? Okay. So that's why in Olympics, so I think Chopra, he he projected javelin. If he projected at 45 degrees through the horizontal, the javelin will go to maximum range, then he will win. So because of the theta here only, the range will maximum at theta equal to 45. So if we project a body, if we project, or if we while we are playing cricket also, if we hit a ball, if we give velocity to that ball, that velocity should make with the horizontal 45. If it make angle, the ball velocity, if it make angle with the horizontal, if it is 45, the ball will go maximum range, the ball will reach maximum height. That means, so finally I want to say, simple, if we want, see, this is the cricket ground. So here is the player. If you want to go this, if you want to reach the ball to here, this is the maximum. If it is maximum range, he wants to hit the ball. If you want to hit the ball at 45 degree with the horizontal, then the ball will go to maximum range. If he hit 90 degree to the ball, the ball will go then somebody will catch the ball. The batsman will goes to out. If he hit the ball at 60 degree, the ball will go like this. In this time also, there is chance of out. Somebody will catch in the ground only. If we hit with 45 degree with the horizontal, the body will reach maximum range. That means beyond the stadium where the spectators will sit there, the ball will goes to there. If we hit the ball at 45 degrees to the horizontal, so for example this is the horizontal, if we hit like this, the ball will go maximum range, it will appear maximum range. Otherwise if we hit the ball upside, the ball will go up and down. Simply we can catch the ball. Okay, this is the physics and cricket. Okay, next. So what is the relation H max at theta equal to 90, H max maximum height u square by 2g. So we can write, so what about R max range equal to u square by g, u square by g. So we can substitute here. So multiply with 2, so 2 u square by 4g. So u square by 4g, so u square by 4g. R max, how do we substitute here? U square by g, this we can substitute u square by g. Otherwise this simply we can do simply H max at theta equal to 90, u square by 2g. So R max equal to u square by g. We substitute just R max into g by 2g. So R max by g. R max by, so g let's cancel, R maximum by 2. Okay, you just write this one. First, okay, next velocity at top point at maximum height. Velocity at maximum height. Look here, this is x-axis, this will become y-axis. This is velocity, this is the maximum height, the body reached at maximum height. What is the velocity components? So this will become ux, uy. So here only ux component is there, that is equal to u cos theta. So what about uy? So here vx equal nothing but ux. There is no change in horizontal component. See here also velocity is there, that has two components, vx and vy. Initially ux, uy, at maximum point it has vx and vy components. Vx is nothing but ux, vx component, there is no change in horizontal component, that becomes u cos theta. What about this one? At maximum height vy component will be 0. Vy component will be 0. Vx component is that is equal to ux, that is equal to u cos theta when we projected. Okay. So my question is, velocity at top point, vertical component of velocity is 0 at top point, horizontal component of velocity is equal to u cos theta. U cos theta. This is you have to remember. You just draw this figure simply. Initially it has an initial velocity u, it has two components ux and uy. ux is nothing but u cos theta, uy is nothing but u sin theta. At maximum height point, it has two components, vx and vy. So vx is nothing but ux, that is equal to horizontal component of initial velocity, that is equal to u cos theta. And what about vy? Vy is equal to 0. So at maximum point, vy is 0 and ux is u cos theta. Okay. This just you write this figure and the concept. Next, velocity it is striking the point. Velocity at the striking the ground. Velocity at the striking the ground. See, here also we will see. See, we calculated velocity at the top point, so striking the ground. So what happens here? Just you check it. X-axis, y-axis. So we projected with u velocity. The body will go like this. Okay. So velocity, it has velocity ux component, uy component. So the angle is theta. Already you know this one. So what about velocity at this point? Initially it projected with velocity u. What about velocity it is striking the ground? At this point, what is the velocity? This is the question. So just think it for 1 minute or half minute at least. How do we calculate this velocity here? Have you any idea? Just try it. Come on, start. Just think it. See what happens here. The body starts at origin and finally reached the ground. So in vertical space, the body acquired displacement sy equal to 0. Sy equal to 0. That means, well, displacement acquired by obliquely projected body in vertical direction is 0 because the body starts here and falls on the ground only. There is no vertically displacement of obliquely projected body. There is no vertical displacement. Horizontal displacement, that is equal to sx, that is equal to range, that is equal to u cos theta into total time of flight. So my question is, what about the velocity here? Here the velocity at maximum point ux, that is equal to vx. So I want to write first vx, then ux, that is equal to u cos theta. There is no vy equal to 0. So what about this point? So just we start doing simple calculation here. So initially it has vertical displacement u sin theta uy component. So here the final velocity at maximum height, it is 0. What about here? So just we have the equation v equal to u plus at. V equal to u plus at. What about vy uy plus ay into t? Here t is nothing but total time of flight. So I want to calculate velocity here. So total time taken by the body is, that is equal to total time of flight. Is it or not? Total time of flight. So vy equal to uy. What about uy? Uy is nothing but initially it starts in vertical direction u sin theta. Ay is nothing but already I given ay equal to minus z. T is nothing but total time of flight 2u sin theta by g. G gets cancelled. G gets cancelled. You will get vy equal to minus u sin theta. Minus u sin theta. So just now think it. What is the velocity at this point? So initially in vertical direction, it starts with u sin theta, u sin theta here, u sin theta here, u sin theta here, here the u sin theta will be 0. Then Vx, here it is Vx is there, Vy, Vx, Vy, Vx, Vy, Vx, Vy, then Vx, Vy, then Vx, Vy will be in this direction. That's why we got Vy equal to minus u sin theta, it is striking the ground. When we projected a body, the body reached to the ground. The velocity, what is the velocity, vertical component of that body is equal to minus u sin theta. That means initially uy equal to u sin theta. Finally you got minus u sin theta. That means simply the velocity direction opposite to the initial velocity direction. Initially the velocity direction is upward. When the striking the body, striking the ground, the velocity direction is downward. So opposite to the initial velocity direction, that we are it shows that only. See, initial velocity, the vertical component of obliquely projected body, initially it is u sin theta is upward direction. When the body is striking the ground, the velocity direction is in the opposite direction. That's why Vy equal to minus u sin theta we got. So I want to explain in the picture clearly. See what happens. See, look here. You just draw it clearly. I will repeatedly I am drawing this one. See, projected u, so this will become ux, this will become uy, u cos theta, u sin theta. The vertical component of obliquely projected body is u sin theta. It is initially. When it is traveling in the air, see the body velocity at this point, for example, take A, take B, take C, take at D. So I want to check A, B, C, D. What about velocities? What are the velocities will be there? Projected theta at point A, it has ux, vx, vy. At this point, vx is nothing but ux. What about vy? Vy equal to 0. Whatever at this point, here it is there, vx equal to ux only, but the velocity vy in downward direction. The velocity, the vertical component of velocity, the downward direction. See, initially it is there like this. Initially like this. Vx, ux, uy. It is moving. Vx, vy. Vx is horizontal. Vy is vertical. Then what about here? Vx equal to ux, vy. It is 0 here. Then what happens here? Vx equal to ux. The velocity, vertical velocity component direction in downward direction. So at this point, what happens? Vx, then Vy. See, initially Uy start with u sin theta. Here you will get minus u sin theta. This is a simple diagram. So from this diagram, what you will get? So what is the information we are getting? See, Vx, Ux. Here also Vx equal to Ux. Vx equal to Ux, Vx equal to X, here also Vx equal to is X, Vx. So throughout the journey, what is happening? The horizontal component of velocity, that is equal to u cos theta, is constant. U cos theta is constant. So horizontal component of velocity in obliquely projected body, the original component of velocity, that is ux equal to u cos theta, is always constant. So which is varying here? The vertical component of velocity is varying here. Initially, vertical component of velocity is equal to u sin theta. At maximum height, vertical component goes to 0. After that, the vertical component of velocity opposite to the initial velocity of vertical component, that is equal to, that means u sin theta is positive direction, uv sin theta, here u sin theta is negative direction, opposite to the initial velocity direction. So this is the situation in obliquely projected body. So I discussed in different cases up to here. If you not copy, just copy the figure. From this figure you can understand everything. So what is you have to, which information we are getting here? Just I want to explain one more time. So if we projected with velocity u, the horizontal component ux, vertical component uy. I am repeating. At maximum height vx equal to ux, vy equal to vertical component will be 0. At striking at the striking ground, vx is equal to ux, that is constant. Horizontal component always constant in obliquely projected body. What about vertical component? The vertical component is changing. Initially it is u sin theta. At maximum height the body's vertical component is 0. The vertical component of body at striking the ground, that is equal to minus u sin theta. The direction is changing. This is a simple. You just draw this figure. So what about obliquely projected? Ay equal to acceleration equal to ay equal to minus z. Then ax equal to 0. The acceleration along the x-axis, along the horizontal, that nothing is there. Along the horizontal direction, acceleration is not there. Along vertical direction only acceleration is, that is towards the ground. That's why we are keeping ay equal to minus z. Okay. Thank you. I will give one problem. I want to solve one problem. Total time of flight. We have the formula u sin theta by g. You just calculate at theta equal to 90. If we projected a body perpendicular to the surface, perpendicular to the earth, what about total time of flight will become? 2u by g. Is it? Theta 90, that means sin 90 is equal to 1. 2u by g. This is equal to vertically projected body up. See that total time of flight, vertical projected body. Just you remember, go to back last classes. TA ascending time, TD descending time, total time of flight, that is equal to 2u by g. We calculated. Just remember it. Go to back pages. You will get same formula 2u by g. So here this formula is regarding to obliquely projected. Here theta is oblique projection. That angle is making with the horizontal. So if we substitute theta equal 90, then will become sin 90 is equal to 1 to u by g. That is equal to vertically projected body upward. So that is total time of flight. So vertical projected body, vertical of that means it will go up and down. So this is ascending time. This will become descending time. Total will become t u by g, u by g. That only we got here. Yes, I am comparing with vertical projection and obliquely projected body. So next, one more. Maximum height also we can do like this. Maximum height u square sin square theta by g. Here also substitute theta equal to 90. So you will get u square by g. U square sin square by 2g. Maximum height u square sin square theta by 2g. If we substitute theta equal 90, sin 90 will become this. Sin 90 will become 1. U square by 2g. This is also equal to vertically projected body upwardly projected body. The body reach maximum height, that is equal to u square by 2g. But this formula is because belongs to obliquely projected body. If you substitute theta equal to 90, that is equal to u square by 2g. That is equal to vertically projected body, vertically projected body upward. So simply just if we substitute 90, every formula goes to, every formula changes to vertical projected body, like a vertical projected body. The formula changes to vertical projected body. Next, R max. What about R max? Range equal to u square square u square sine 2 theta by g. If we substitute theta equal to 90, what happens here? Range equal to 0. See, this is the range formula we got in vertical obliquely projected body. Obliquely projected body, the range, maximum range, the range of the body, we have u square sine 2 theta by g. When theta equal to 90, sine theta 2 into 90, sine 180 will become 0, u square range equal to 0. If we project vertically, that is making angle 90 with the ground. If we project like this, what happens? It will go up and fall on the same place. The range will become equal to 0. That I am comparing oblique projected and vertically projected. So this is also one more important point. Next, so obliquely projected. These are the important points. You just go through what I given the points. Just understand, read well. Tomorrow I will give one more new topic to you. Thank you. Okay, bye.